everybody, Dr. Swart here with BP Training Systems. Today I'm going to talk to you about a topic that is thrown around in exercise science and really gets, misconstrued in many different ways, and that topic is lactate. And when I talk about lactate, especially in my classes, one of the first things I talk to them about are these two kind of baseline premise statements that I think you have to understand before we move forward in talking about really what lactate is. So essentially this video today is going to give you what you need to know, the basics about lactate, and what you need to know in order to be effective as a strength and conditioning coach or a practitioner in any way, shape, or form in this field. So number one is I always make sure that people understand lactate does not cause muscle fatigue or soreness. Now, when you do a particular exercise protocol that's high intensity that may lead to soreness or fatigue, we know that lactate typically is generated in high concentrations. So it's associated with fatigue and soreness, but it's not the root cause of it. And we know that there's a lot of different causes of fatigue and soreness that we're not going to get into in this video, but it's not directly because of lactate. Lactate is actually a good metabolite for us. It's helping us in the process of exercise. The second thing that I think is really, really important to understand is lactate can be used as an energy source. So at one time point, people used to think that we just generate lactate. It's kind of this dead-end metabolite. We don't really do anything with it. It's just there. Well, we now know that we can break it down and oxidize it for fuel, just like we do carbohydrates, for example. So it's really important to understand those two key fundamental statements. The other thing that's important to understand is you're always generating lactate. So even at rest, when you're sitting there watching TV, you have a certain amount of lactate that's floating through your bloodstream. And typically it's somewhere between 1 to 2 millimoles per liter. Now I know those units don't probably mean a whole heck of a lot to you guys, but essentially it's very, very low. During all intensity, like a high intensity exercise session, if you're doing interval sprints on a bike, for example, you could get 10, 20, if not more times that lactate that's in your bloodstream than just the 1 to 2 millimoles. So obviously it can increase very, very quickly into a very large amount. Now, what does that mean and why do we need it? What are we going to use it for? Essentially, I always want to make sure that people understand the term lactate turnover. So at rest, when you're just sitting there watching TV, the amount of lactate that you're generating, for the most part, is the same amount of lactate that you're clearing and metabolizing and getting rid of it. So it's not building up in your muscle tissue or your bloodstream or anything like that. So that's what we call lactate turnover. Now, at some point during exercise, I'm going to be generating more than I'm actually able to clear. And that's when you start to see it get built up into the bloodstream. So before I talk about where we're going to use lactate, I think it's important for people to understand where is lactate coming from. So lactate comes from an energy system known as glycolysis. So essentially glycolysis, if you think of glucose, it sounds like glyco, and if you think of olysis, means breaking something down. So glycolysis is nothing more than the breakdown of glucose, the breakdown of carbohydrates. So we know that we can break down carbohydrates very rapidly. And if I were to go do an all-out sprint activity, if I were to go and do interval sprints on a bike, for example, during high intensity effort, carbohydrates are my dominant source of fuel. So what's happening is when I go through this process of breaking down glucose, if I need a lot of energy very quickly, which would be that example of doing bike sprints, for example, I don't have the time in order to recruit the mitochondria and start to utilize the mitochondria and for oxidative metabolism. I have to keep energy high. I have to keep ATP being produced at a very rapid rate. So what's happening is within the cytosol, or that fluid component of the cell, that's where I'm breaking down glucose. And before we shuttle one of the byproducts into the mitochondria, we just simply convert what's called pyruvate into lactate. So pyruvate would be one step in the process before we bring it to the mitochondria to get more energy and more ATP. Essentially, that's all we're doing is we're stopping the process in the middle. So we're basically taking glycolysis, we're going through all the steps in the cytosol, the fluid component of the cell, and we generate this lactate molecule. And now some people will say, well, why do we do that? Well, we do that because I'm also going to generate another molecule known as NAD. It stands for nicotinamide adenine dinucleotide. Big long word, that's not really as important. Basically what you need to know is that NAD carries electrons to the mitochondria. So in order for glycolysis to keep going, you're going to need these NAD molecules present. So essentially what's happening is I break down carbohydrates, I get to what's called pyruvate. Instead of going and bringing all this stuff into the mitochondria, I simply just convert that pyruvate to lactate. And now that lactate, when I convert it to the lactate, now I'm also going to generate this NAD. And that NAD goes in the cycle of glycolysis to keep it going and to keep you generating a lot of energy quickly. So if you're going to do something that's high intensity, we want to convert pyruvate to lactate so we're able to get that NAD and keep that rapid replenishment of ATP coming. Now the question becomes, okay, so we've got this lactate, now what the heck do we do with it? Well, we can utilize lactate really in 3 different ways. The first way we utilize lactate is, let's say for example, I'm doing that same example, the bike sprints, and I'm generating a lot of lactate in a certain muscle fiber. Well, I can take that lactate and actually shuttle it into the mitochondria, and I can convert it essentially back to pyruvate and then to what's called acetyl-CoA and go through what's called the Krebs cycle to generate more energy. So that lactate doesn't just disappear and isn't used for anything. We can actually use it within the same muscle fiber that it was created in, and we can get more ATP from it. Now, we also have these specialized transporters that are on the cell membranes of muscle cells. So we can take that lactate and actually transport it to a neighboring muscle fiber. So for example, we typically generate a lot of lactate in type 2 muscle fibers, those fast twitch fibers. And we know that type 1 fibers are more oxidative. So during exercise, I can simply shuttle the lactate from a type 2 fiber, shuttle it to a neighboring type 1 muscle fiber, utilizing those specialized transporters, and then do the same process. I can convert that lactate back to pyruvate, then to acetyl-CoA, which will then go through the Krebs cycle and create more ATP, more energy from that. Now, the third way that we use lactate, and this one kind of trips up students a little bit in my courses all the time, but you can actually take lactate utilizing the same specialized transporters, bring the lactate, dump it into the bloodstream, and that lactate will then move in the bloodstream, it'll go to the liver, and the liver can go through a process known as gluconeogenesis. So gluco meaning glucose, neo meaning new, genesis meaning the creation of. So essentially that lactate that was generated in the muscle fiber can then transport into the bloodstream, make its way to the liver. Through a process known as gluconeogenesis, the liver can convert that lactate into glucose, sugar, now get dumped back into the bloodstream, and working skeletal muscle can take it up and utilize it for fuel. So really those are the key things that I think you need to know about lactate. You have to know that it does not cause muscle fatigue or soreness. Muscle fatigue is a very, very complex topic that has a lot of different factors to it, but lactate is not causing it. We also know lactate can be used as an energy source, and it's important to know in what ways. I can use it in the same muscle fiber that it was generated in. I can use it in a neighboring muscle fiber, typically more of an aerobic fiber that can break it down more effectively. And then I can also shuttle it to the liver, and then the liver can convert it to glucose, which can then be used in skeletal muscle for exercise, empowering exercise. Hope this video helped as far as giving you a broad overview. As always, let us know if you have any questions, and we're happy to answer them.